Hey guys, so today we're going to look at sinusoidal application problems, and there's actually quite a few number of applications in real life that can be modeled by a sinusoidal wave. And one example is temperature. So if we look at how temperature varies, it actually varies sinusoidally on a certain day in May. And so the minimum temperature, we're going to say, is 55 degrees at midnight. And then as the day goes on, the temperature increases and you've got a maximum temperature of 70 degrees at noon. And then as the night comes, the temperature goes down again, and it kind of follows that sine wave model. So let t be the number of hours since midnight. T equals 0 is midnight. The first thing they want us to do is graph two periods of the function, t of t, so temperature as a function dependent on time. And so you can see that I started my graph with my x-axis representing the time. 0 is midnight, and so noon the next day will be 12 hours after midnight, and then 24 would be the following day, midnight, and then plus another 12 hours would be noon that following day, and then plus another 12 hours would be 48, that would be midnight that next day. Okay, and then y represents our temperature. We know that the lowest is 55 and the highest is 70, so I just got to make sure that it reaches up to 70. And from there, we're just going to make our graph. So we know that at midnight, t equals 0, it is at 55 degrees, so here it is. And then at noon the next day, it reaches a high of 70. Okay, and even though they only give us 2 points here, because we know it's a sinusoidal function, it fits a sine wave, all we need are the 2 points and then we can connect the dot, right? All we need is the high point and the low point, because I know that between the low point and the high point, it's going to cross over the wave axis somewhere, and then it's going to cross over again and hit another low and then go back up and hit a high. So we know that at noon, it goes to 70, and then temperature is going to decrease. At midnight the next day, it's going to be back down to 55. And then noon that following day, it's going to go back up to 70. And then finally, midnight that following day, it's going to come back down to 55. And so it just repeats. And so we really just need 2 points, and then we can draw our sinusoidal function. Right, there it is. Okay, and so the next thing it's going to ask us to do is write an equation for this function using a sinusoidal function. And so when we write an equation, there's a couple of numbers that is going to help us, because we do need, remember, the equation is y equals, right, or in this case t of t equals my amplitude a, and then either sine or cosine, whichever. And then we've got b, which is the frequency, times x minus h if we have a horizontal shift, and then plus k if we have a vertical shift, in which case we do, that's where the wave axis is. So if we can identify all of these helpful numbers, it's going to help us with the equation. And the minimum we know, minimum is at 55, maximum is at 70, okay? And the amplitude we know is the distance from the wave axis to the top, the high point, and the distance from the wave axis to the low point. So to find the amplitude, all I have to do is take the difference between the high and low point and divide by 2, right? So if I do 70 minus 55 divided by 2, that's going to give me 15 divided by 2 is 7.5. So I know that from the middle to the high point is 7.5, and from the middle to the low point is also 7.5. That's my amplitude. Well, then using that, I can find where that midline, that wave axis is. So my lowest point is 55. 55 plus 7.5 is going to give me 62.5. That's the middle. I'm going to just do a quick sketch here. 62.5 is going to be right here. That's my wave axis. Okay. And then finally, my period, remember, one period is where I can draw one full cycle, right? So it's really just the distance between the two high points or the distance between the two low points. So right here at noon, I know it's at 70 degrees. The next time that it hits this exact same point is noon the next day. So after a span of 24 hours. My period is 24, and that's going to help me find B, my frequency, right? Because remember the formula, 2 pi over P, 2 pi over my period, will give me my frequency. So 2 pi over 24 is going to give me pi over 12. That's my frequency. All right, so with all these numbers, we are ready to write our equation. We know A, the amplitude is 7.5. We know K, the vertical shift, or where that wave axis shifted up to, is 62.5. And we also know B, which is pi over 12. That's the frequency. So the H value that we're going to figure out depends on whether we want to write a cosine or sine function. And that's entirely up to you, although I think it's a little bit easier if we write a cosine function, only because it's easier to identify where the high-low points are, because this is my cosine, right? And I already know where this point is. Versus if I want to write a sine function, that starting point is right here where the wave axis is. That would be one full cycle of the sine function. And this is kind of hard to see where it is, and we have to estimate it. It's not given to us. So the easier thing to do, if you are given a high and low point, would be to write a cosine function. Okay? So two options here when you're writing that cosine function. The first option is, let's say my cosine starts with this high point right here, crosses over the wave axis, hits a low, crosses over, and hits back up to the high. Okay, in this case, my function would be y equals, or in this case, t of t equals, you could write y equals, it doesn't matter. A is 7.5 times the cosine of pi over 12, and then x, since I shifted over 12 units, because I'm starting at noon, it's going to be x minus 12, and then plus my k, which is 62.5. Okay, so here is one possible equation to represent this situation. Also, if you want to, another way to do it is if you want to say that, all right, instead of starting here for cosine, what if I start here? It's just a flip, right? Instead of starting at a high point, I can make my A negative, and then I can start at a low point, and that would give me, if I start here, low, high, low, this would be one cosine wave, okay, except negative. So another possibility is t of t equals negative 7.5 cosine of pi over 12 times just x in this case, because I'm not shifting left or right. I'm starting right here at 0. I just flipped it over and reflected it over that wave axis. So just pi over 12x, and then plus 62.5. Oops. Okay, should be t here, not x. Should be a t. All right, so as you are writing these equations, you can have more than one possible answer. Entirely up to you. Okay, let's take a look at C and D. Use your equation to find the temperature at 10 a.m. So we know that 10 a.m. is when t equals 10. That's 10 hours after midnight. And we're going to use one of our equations. So y equals, let's use that second one. since it's a little bit shorter, negative 7.5 cosine of pi over 12 times t, right, plus 60, forget what it was, 62.5. Okay, and so plugging 10 in for t, negative 7.5 times the cosine of 10 over 12 pi, so I can reduce that to 5 pi over 6 plus 62.5, and just make sure that you, when you plug into the calculator, you are in radian mode. Okay, although you can probably calculate the cosine of 5 pi over 6 yourself. 5 pi over 6 is in quadrant 2, right, with a reference angle of 30 degrees, pi over 6. And the x, cosine is x, would be radical 3 over 2, again, and it's negative. Negative radical 3 over 2, plus 62.5. Okay, and that, putting that into your calculator, gives you 68.995, which is about 69 degrees. So about 69 degrees at 10 o'clock in the morning. And then the last part is I want to go on a bike ride on this day. Now, if I want to go on a bike ride on this day, but I prefer to ride when the temperature is at least 65, what is the earliest time of the day that I can leave for my ride, and how long can I stay out before I get cold? So for this, we're just going to estimate on our graph instead of calculating algebraically. We're just going to look at our graph and estimate. So I want to ride when the temperature is above 65. So going back to my graph here, so I have written all over it already, but here is 60 and then 62, so like 65 would be like right here. Okay, this is when it starts hitting 65, and then the next time it hits 65, according to my graph, just an estimate here, is right here. So it looks like this is the time where I can be riding my bike. So estimating it down here, it looks like maybe 2, 4, 6, maybe at 7 a.m. I could start riding my bike, and then 12, that would be 2, 4, and then maybe 5 p.m., right, is when the temperature is going to drop below 65. So just looking at your graph and estimating. Okay, so between 7 a.m. and 5 p.m. is my guess. Between 7 a.m. and 5 p.m. is when the temperature is going to be 65 or above. So for your practice, you're going to pick 2 problems to do, and you're going to do the exact same thing. Sketch out a graph. Make sure you label the axes. By sketch, I do mean just label and make sure that you're as accurate as possible, although it doesn't have to be perfect, because you're going to use your graph to help you answer the questions that follow.